Hello, welcome to today's class. We have an algebraic equation before us here. It's a nice one. The question is a times a times a times a all over a plus a plus a plus a equal to 16. What is the value of a here? Now, at first, you can tell straightforward the number of roots we are going to get from this challenge here. Okay, here we have 4. And at the bottom, we are also having 4. So I never think we're going to get 4 roots from this challenge. One of the variable at the bottom, we cancel out one at the numerator. And so we are expected to solve for 3 roots here. Okay, so let's take our solution and see how we solve this or how we go about this. So this will now give us, because here we have the same base number and we have multiplication. So the powers here are just 1, 1, 1, 1. And so we add the powers together. And so this is going to give us our a to the power of 4 all over. Yeah, the variables are the same too. And we have the summation sign here. So we can add them together. And that will give us our 4a equal to 16. Easy. Now we can rewrite this expression by separating this 4 out here. So this is going to give us 1 all over 4 times a to the power of 4 all over a. This is equal to 16. So we have a division sign here. The variables are the same, but the powers are different because here we have invisible 1. So we apply the law of indices, which says that when you have your a to the power of m all over a to the power of n, subtract the powers. So we're going to have a to the power of m minus n. So we can subtract 1 from 4 here. And this will leave the system. And that will give us a to the power of 3. So we have 1 all over 4 times a to the power of 3 equal to 16. So the next thing we do here is just to eliminate this 4 here. And how do we go about that? We multiply both the right-hand side and the left-hand side of the equation by 4. So this is going to give us our 1 all over 4 times our a to the power of 3 times our 4. This is equal to 16 times 4. So this and this will leave. We're now left with our a to the power of 3 is equal to 4 times 6 will give us 24. 24, put that 4. There 4 times 1 will give us 4. Plus the 2 you carry gives us what? 6. So that's going to give us 64. All right. Now, if we decide to take the cube root of both sides of this equation, we're going to come up with just 1 root. But I said we are to look for 3 roots here with this power we are having here. And so we move this side of the equation, which is this quantity on the right-hand side, to the left-hand side. And so this is going to give us our a to the power of 3 minus 64 equal to 0. So having this, what comes to mind is, can we express 64 in a number that we can raise to 3 to give us 64? Yes. If we raise 4 to the power of 3, that will give us 64. And here we are having a power of 3. So let's go ahead and do that. This is going to give us a to the power of 3 minus 4 to the power of 3 equal to 0. So seeing this kind of expression, what comes to mind? We have what is called the difference of 2 cubes. And what does it say? It says that when you have your x to the power of 3 minus y to the power of 3, this is equal to your bracket typing x minus y close bracket, your x to the power of 2 there plus our x, y, there plus our y to the power of 2. Nice one. So this expression we have here now is in this form. We want to take it to this form here. So let's go ahead and rewrite this. So this now implies that our a, bracket of a minus our 4, the close bracket, a to the power of 2, the plus our 4a, the plus our 4 to the power of 2, close bracket, equal to 0. Okay. So we are having this bracket times this bracket equal to 0. We apply a rule which says that your m times n, this is time please, sorry, equal to 0, it means that our m is either equal to 0 or n is equal to 0. So we call this the zero property. So with this, we're going to have first case and second case here. So we have case 1. Case 1, we're going to have bracket open a minus 4 equal to 0. Then if we open this, it's same thing as a minus 4 is equal to 0. Send this to this side, so we have a is equal to 4. This is our a1. The first value or the first root that will satisfy this challenge is a is equal to 4. Okay, so let's go ahead and look for the other two roots, because we have 3. We have to look for 3. We've got to 1, and to get the other 2, we applied this rule, or we take this as the second case scenario. So we have here case 2. So case 2, we have our a to the power of 2 plus 4a, then plus 4 to the power of 2 is 16. So we're going to have here, or let's leave it at this form. Okay, no problem. We go to work with this like this. All right, so this is a quadratic equation. We're going to use the formula method. So using formula method, we have our a is equal to our minus b plus minus the square root of b squared minus 4ac, everything all over our 2a. So let's quickly bring out the value of a, b, and c. Our a is the coefficient of a squared, which is equal to 1, right? Okay, so we have 1 here. Again, yeah, this a is different from this very a here. Okay, so don't be confused with this. So there, our b is equal to the coefficient of just a, so we have here 4, and our c is the constant term, which is 4 to the power of 2. So we want to impute this into this system. So we have our a is equal to minus, where's our b? 4. So we have here minus 4 plus minus the square root, our 4 to the power of 2 minus 4 times 1 times 4 to the power of 2. Everything all over our 2 times 1. Wow. So how do we simplify this? Let's bring out 4 to the power of 2 from here and here, because they are common. So this is equal to, this is the reason why I said no need. Simplify this. So this is going to give us minus 4 then into the square root of our 4 to the power of 2, bracket open. If we use this to divide this, we are left with 1. Then minus, we use this to divide this, we are left with 4. Close bracket, everything all over 2. Okay, so let's continue on this side again and see what this gives us in turn. All right. So this is our square root here, and so we are having 4 to the power of 2. So this 4 can come out. So this is going to give us our a is equal to minus 4 plus minus 4 here, because here we are having square here, and if we take care of the square root here, then under here we are now left with minus our 3, because 1 minus 4 will give us minus 3. Then all over our 2. Wow. So we can rewrite this. Remember that the square root of minus 1 is equal to iota. So we can bring iota into the system. And here we can factor out 2, because we're having 2 at the denominator. So this is going to give us a is equal to 2 into minus 4 will give us minus 2, the plus minus 2, the iota root 3, close bracket, all over 2. So this and this can leave the system. So we end up having our a is equal to minus 2 plus minus 2 iota root 3. Easy. Okay. We can still simplify this down to get our A2 and A3. And so let's write out our A2. Our A2 is going to give us, if we decide to bring out 2 from here, that's going to give us 2, open bracket, minus 1 plus the square, our iota to the square root of 3. Then our A3 will now give us 2 into minus 1 minus I root 3. So these are the other 2 roots, but they are imaginary roots. It is only A1 that is a real root to this challenge. So this brings us to the end of this math class. You've learned something from this video. Do not forget to give this video a thumbs up. Remember, we love you. Thank you for being there all the time. Bye for now.